Welcome students to the session 2 of our series that we are currently doing. I am Vikas, your mathematics teacher. We are beginning with our chapter 1, which was your number system, right? In our earlier lecture, we had understood what is number system, what are the various types of number systems, right? I hope you guys recall everything that we have just understood in our earlier classes. So I will be picking up our class from there. I will be having a quick revision for you guys. I hope you guys have already prepared yourself. But if you haven't, I have a quick revision video. I have quick revision portion right now. So I will be having that in a few minutes. Let's just wait if everybody joins. And I hope you guys already have your pens and notebooks with you. So let's see what do we have in our earlier session. We had this, right? We had understood what number system was, right? That was what? That was the way in which we had arranged our numbers, right? We had arranged our numbers in a particular group, right? Those groups were what? Those groups were your real numbers or some were imaginary numbers, right? I had told you what real numbers are and what are imaginary numbers. You guys should be recalling that. What were your real numbers? Those were the numbers that could be represented easily on number line, right? They could be represented on number line, right? And what were imaginary numbers? Those were the numbers which could not be represented on number line. We could not represent them on number line. Those were what? Those were your imaginary numbers. Now, real numbers were categorized in the following groups, right? Your natural numbers, your whole numbers, then you had what? Your rationals, then you had your integers, and finally you had your irrationals, right? Can you recall any of this? So, natural numbers were what? These were the numbers that were beginning with a 1 and going up to so on infinity, right? They were all positive numbers that were beginning with a 1 and they were ending at infinity, right? Now, what were your whole numbers? Those were the numbers which had every natural number, but they were beginning with a 0. So, in short, a number or a series that begins with a 0 and goes up to so on positive infinity. So, any positive number starting with a 0, that will be a whole number. So we had understood this concept also, right? Every natural number was whole number, and you can see that was here also. Now, what about rationals? So before we get to rationals, I just want to tell you what are integers. So if you had taken the mirror image of your whole numbers, or let's say if you had taken the mirror image of your natural numbers, what I mean with this is if I had any positive number and if I had taken its additive inverse, that means any negative number including a 0. So a series in which you had any positive number or you had any negative number, but you had a 0 in the middle. So that means that series was what? That was your integer series, right? Negatives were on the left hand side of 0 and positives were on the right hand side of 0. Those were what? Those were your integers, right? Now, any number, now we come to the concept of rationals. You guys remember this. So we had any number which could be represented in the form of p by q. That was what? That was irrational. So in short, we had this. We could represent 1 by 1, that was in the form of p by q, and the condition was this: q should not be 0. So we could easily represent our natural numbers in the form of p by q. So every natural number was rational number. We could easily represent our whole numbers also. That means every whole number was a rational number. You guys remember 0 by 1 also is in the form of p by q. So it was also rational. Every integer was a rational number, but the converse was not true. Every rational number could not be a natural number, neither it could be a whole number, nor it could be an integer. So that means natural, whole and integers could have been your rationals, but not the other way around. Now for the last portion, what were irrationals? You guys remember this? What are irrational? Those are the numbers which could not be represented in the form of p by q. You guys remember this? Square root 2, square root 3, square root 5, square root 7, square root 9, square root 6, 9 could be represented in the form of p by q, square root 6, square root 8. So you guys see, these will be what? These will be your irrational numbers. So we had understood this, then we had understood how to find out rational numbers between rational numbers. You guys remember that? 2 by 3, 3 by 4. We did what? We had made their denominator same. We had taken LCM 12. That would have been what? A 6. That would have been a 9. Then we had multiplied with any number that we wanted. Let's say 3 multiplied by 3, 3. So we could find out as many numbers as we wanted. So that would be the case here, right? Sorry, there should be an 8 here. There should be an 8. So this was what we had done in our finding out rational numbers, right? Now we are going to jump towards specifically the differences between rationals and irrationals. Firstly, we are going to understand this. Then I am going to shift towards our total irrational concept here today. So you guys remember what were rationals? They were in the form of P by Q. And the only difference between a rational and an irrational number was what? Any number which could have been in the form of P by Q, that would have been a rational. But if a number that couldn't have been in the form of P by Q, that would have been what? An irrational number, or you can say any number which had a square root over it, or let's say if it was the case of square root, it would be what? It would be an irrational number. That was the primary difference. But there are some various differences also. If we divide them, that means if we go towards our decimal expansions, we have some more differences. So if we divide this, we can have two different kind of expansions. Whether that will be completely divisible, that means it will be terminating expansion, or it will be non-terminating. That means if we divide, let's say if I have 1 by 5, you guys see if I divide this this will be completely divisible, right? This should be 0.2. So this is what? This is a terminating expansion because this is dividing completely. Although this is in decimals, but that is terminating to its finite value. So this was what? This was a terminating expansion. But whereas if I had taken 1 over 3, that would have been what? A 0.333. Now you guys see this value will not stop. These kind of expansions are what? These are your non-terminating expansions. We will be understanding these cases deeply later on. So just remember this. For now, difference between rational and irrational is that rationals can be represented in the form of P by Q, whereas irrationals cannot be. But there will be a difference on the basis of their decimal expansions also. So once we get to the point of expansions, I will be explaining the difference there. Just for now, remember this. This is the basic difference that you guys should be knowing. I hope you guys get the point here, right? So rather than wasting your time, let's just jump towards our irrationals now, because that is the elephant in the room. So our basic thing is now representing an irrational number on number line. So I had showed you how to represent your whole numbers on number line, how to represent your naturals, your integers, or even rationals also. But now the concept is how to represent an irrational number on number line. That means how to represent a square root a. Now you guys see, let's say I have square root 2. I want to represent this on number line. Now you guys should be recalling your long division method from your class 8. You guys should be doing it with long division, right? So if I try to find out its square root to its nearest decimals, what should I get? Let's see. I have 2. That should be 1. That should be 1 here, taking a decimal. That will be 100. Twice of this would be what? It will be 2. I have to think of a number which should be nearest to this 100. And I have to multiply it with same number. So that should be what? 24 into 4. That will be what? A 96. Then you have what? This is 4. Again you will be having 100. So multiplying this with 2, you will be having what? A 28. Then you have to think of a number which should be near to 100. So that should be what? A 1, and this will be 281. If you solve this, you will be having what? 119, and there will be 2 more zeros. So you guys see, this number is not terminating, it is going on repeating, or sorry, it is not going to repeat even, it is going to be continuing while we are dividing it. So we will not be having any finite value here. Remember this, while you solve any irrational number, you will never be getting any finite value. That means that answer will not be terminating. So if you try to solve this one, this will not terminate to its nth place. You can just keep on solving this. You will be having different numbers as your quotients, but the answer will not be terminating. That means you will never be getting a remainder which will be 0. This cannot happen in the case of irrational number. If you want to verify this one, just verify this on your own. You will be getting it that this is not terminating even. So these kind of things happen for irrationals, and once the number is not terminating, how can we represent that number on number line? So that is the basic concept that we have to learn here. And for this, I am going to bring you towards your Pythagoras theorem. You guys remember your Pythagoras theorem? It was what? It is this. If you have any right angle triangle, let's say this is your right angle triangle ABC, where right angle is at B, One would be your perpendicular, one would be your base, and the side opposite to your right angle, that will be your hypotenuse. Now Pythagoras theorem states that square of your hypotenuse is same as square of perpendicular added to square of base. Or in short, you can say hypotenuse will be what? Square root perpendicular square plus base square. So that is what? That is your Pythagoras theorem. The reason why I want you guys to remember this or just understand this is that, let's see, if I have a square root 2 and this is what we have to represent on number line. Now think of this. Can I write square root 2 like this? 1 plus 1. Obviously I can, because 1 plus 1 will be what? It will be 2. And you guys remember square of 1 is obviously 1. So we can even write it like this. Square root 1 square plus 1 square. Now if you compare this here, if you compare these two equations, in place of hypotenuse you have a square root 2. In place of perpendicular square you have what? Square of 1. In place of basis square you have what? Square of 1. So if I just substitute the values here, I will be getting perpendicular, which is what? It is 1 centimeter, or you can say 1 units, and I get a base which is also what? 1 units. So if I use this, and ultimately if I just try to build up a right angle triangle, considering this is my base which is 1 and this is perpendicular which is 1, I can easily mark out my hypotenuse. How will I be doing that? Let me just erase the portion here. Let me just erase this. And remember this, we have perpendicular which is 1 unit and we have base which is 1 unit, right? Now do what? Just draw a number line. Let's say this is your number line beginning with a 0. Now you have to do what? You have to take a base 1 units. So I am going to assume that the base is of 1 centimeter. So let's say this is my mark here. This is OA, which is what? Base, and it is 1 centimeter. Now you guys remember we have the base which is 1 and a right angle was at B. So that means right angle should be here. Now we have to do what? Considering our O as the center, we will be putting the compass here and we will be constructing a right angle here, right? So you guys remember how we are going to construct this one. So construct that. This will be an arc of 60 degree, that will be an arc of 120. Bisector of these two angles, that means this here, that will be what? That will be a 90 degree angle, right? Let's say this is your right angle, right? Now you guys remember we have the perpendicular which is what? It is 1 units. Perpendicular is also 1 units. Now you have to do what? Again, firstly you have to open your compass up till of arc 1 unit. Now you have to mark your compass with an arc of 1 centimeter. In our case we are assuming it to be 1 centimeter. So open up your compass of arc 1 centimeter, put it again on your O, which was your center for your right angle. Just mark your 1 centimeter here, assuming this is 1 centimeter. So that should be what? That should be 1 centimeter as well, right? Now you have to do what? Just join this one, join this point here. Now do what? Marking this, just do what? Draw your right angle here. So this will be what? Just extend this one, this point right here, this will be what? This will be a square root 2. Assuming this one, putting it here, just draw out your compass, that will be what? That will be your square root 2. I hope you guys have understood the case. So I hope you don't have any doubt here. That will be the point. This is how you can do it. So I hope you don't have any doubt in this, right? You will be taking 1 centimeter here. You will be taking 1 centimeter here. Then opening the compass till here. Then you have to do what? You have to just mark out your line here. That will be what? That will be your 1 centimeter arc. Just putting it here, start marking your arc here. Wherever it reaches, that will be the case, right? Now let's see what do we have in the next part. So using this, you can just make up, actually this will be the case. We will be putting the compass here and then we will be drawing it. That will be the case. We will be putting the compass here. Then you will be getting it here. Understood? Now using this, you can draw this spiral also. I will be telling you how you can draw this. So see, for this, let me just go back and let's just start drawing it again. Let's see, we had drawn square root 2, right? Now we want to draw square root 3. How we can do this? Let's see, it is very easy. Can I write square root 3 like this? square root 2 whole square and a 1 whole square. Because you guys see, this 3 can be written like this, 2 plus 1, right? And this 2 can be written like this, square root 2 its whole square and 1 its whole square, right? We can do it like this because square root 2's whole square will be 2 and square 1's whole square will be 1. 2 plus 1 is what? It is ultimately 3. Now you guys see, if I compare this one with our what? Our h square is equal to p square plus b square, or you can say h, which is equal to what? Square root p square plus b square. That will be what? That is a Pythagoras theorem. Now you guys see, our hypotenuse is what? It is root 3, and this is what? Our perpendicular square is what? It is root 2 square, and base is what? It is 1. So perpendicular is what? It is root 2, and base is what? It is 1. Now you have to do what? You have to firstly mark out your perpendicular, which is root 2. Then you have to do what? Then you have to find out root 3 there. So how we are going to do this one? For this, firstly we have to assume our perpendicular. We have to find this one out. Then we have to draw that. So how we are going to do? Let's see. For this, we are going to repeat our process here. Firstly, we are going to point out our root 2. So let's say our root 2 is this. It can be written like this, 1 plus 1 square and square. So perpendicular is 1 and base is 1 centimeter. So again, we are going to do what? We are going to mark out our line, which is this one. Assuming this our starting point, which is 0, and let's say this is our point A, and this is 1 centimeter. This is our base. Now we are going to do what? We are going to draw a right angle here, which will be like this. Let's say this is 90, that is 90. Sorry, this is 60, that is 120. Bisector of those, this will be 90. Just point it out. So this is what? This is your right angle, right? Now you have to mark out your perpendicular, which is 1 centimeter. So let's say this is 1 centimeter. Join this one. Put your compass here and do what? Put your compass here. Open up the compass of this much length, because we have to do what? We have to point out our root 2, right? So this length is actually what? It is root 2, right? So if we find out our length, which is root 2, and if I put my compass here, and I can easily mark out what? My root 2 also. So if I have just assumed my compass of this much length, this much arc, I will be putting the compass here. Then I will be doing what? I will be marking out my root 2. Let's say this is the point here. So this point right here will be what? It will be root 2, or you can do what? Just put compass here, just mark it out. So this will be what? This will be your 2. I hope you get the point here, right? So now you had what? You had root 3, right? We had to represent root 3. For this, you can do what? I had told you this will be what? Root 2 square plus 1. So for this, I want you guys to assume this one to be your base and this one to be your perpendicular. Now if this is the base, this is root 2 here. So if I erase this one, since I have represented root 2, so if I erase this, this is the root 2 here, that is my base. I have to point out 1 centimeter perpendicular again. So this is the right angle, 1 centimeter is here. I will be doing what? I will be joining this point, that means here till here. This length is what? It is now root 3. I will be assuming this as my arc for the compass, putting it here, marking out my point. That will be what? That will be root 3. So similarly, you can just keep on doing this and you will be constructing your spiral also. Now this is the simplest method in which you can just go on assuming your square root values as your bases. But if you don't want to assume that as your base, then what would you be doing? You can do it like this. See, if I erase this and if I just do it like this. Now you guys remember, this was, let's say, my 1 centimeter perpendicular, and this was my 1 centimeter base. This was my height, with hypotenuse, which was root 2. So if I just assume this as my arc, that will be root 2 point here and that will be root 2 point here, right? So if I assume this as my perpendicular, I can do what? That is root 2 here. I will be doing what? I will be drawing a right angle here like this. That will be the right angle. This will be the case. It should be actually different, but you guys see how we are going to do this. So this will be a right angle. Again, you will be marking a 1 centimeter arc. Then you will be joining this one. Then you will be doing what? Again, putting it here. So you can easily represent your angles using this method. That will be the case of your spiral. See what we have here. this was the case. Let's say this was your base, which was 1 centimeter. We assume this one to be our perpendicular. So you guys see that will be 1 centimeter. That will be what? Our hypotenuse. You can just easily draw your line, right? Then you can do what? You can just put out your right angle triangle here. Then you can do what? You can just draw your 90-degree angle here. Then just go on. Then mark your point. Then you will be doing what? You can just go on like this. So I had taken the other way. Our spiral will be moving on the left side. But in this case, you can just assume this one. This will be going on your right hand side. So I hope you guys easily understand this, right? So we have some examples here. So we have to locate root 2. You can easily locate that since we have already done this. Now we have to locate root 3. We have already done this one. So you can do that also. Now we have some questions here. State whether the following statements are true or false. We have to state that whether the statements are true or false. Is every irrational number a real number? You guys already remember this. Real numbers were what? They were rationals also. They were irrationals also. So this is what? This is true. Every point on the number line is in the form of root m, where m is a natural number. See, can this be happening? Obviously it can be. See, root 2, root 3, root 4. So this is true. Every real number is an irrational number. Can this be the case? Can 2 be irrational? Obviously it cannot be, because 2 is what? 2 can be represented in the form of p by q, which is false. So this should be what? Should be false here, right? Now we have what? We have this question. Are the square roots of all positive integers irrational? Can squares of all positive integers be irrational? Can this be happening? Square of all positive integers irrational. Square roots. See, if I just find out the square root of 4, can this be irrational? Obviously it cannot be. It will be what? It will be 2, which is rational because it can be represented in the form of 2 by 1, which is in the form of p by q. So this is not irrational. Although if there had been some finite cases, let's say if they wanted you to be having a square root 2, a square root 3, a square root 5, then it could have been happening there, right? So that would have been the case. We could have said these three would have been what? These three would have been your irrational. But since the cases of every positive integer, that cannot be the case, because we can have a 4 there, which is a square of 2. We can have a 9 there, which is a square of 3. We can have even 16. Then we can go on like this. Those can be represented easily in the form of p by q. So that cannot happen there. See, I will be telling you how to construct this using this method. So we will be constructing with this one. So that is what we are preferred in our exams. So in this method, I am going to use that one. So you have what? You have root 5. You have to represent this on number line. Now you guys see, root 5 can be written like this, 4 plus 1. Obviously we can write it like this. Can root 5, can this be written like this? Square of 2 plus square of 1, right? Square of 2 is what? It is 4. Square of 1 is what? It is 1. And you guys see, this will be giving me what? It will be giving me root 5. If I compare this with my Pythagoras theorem, that means h, which is equal to what? Square root p square plus b square. I have p, which is what? 2. I have b, which is what? Which is what? A 1. Now choice is yours. You can even interchange them. Totally your choice. But since you are going to do it like this, I am going to assume b to be 1 centimeter and p to be 2 centimeter. So let's see what we have to do here. So this is my line segment. That is my starting point O. That will be what? A 1 centimeter base. Let's say this is point B. I am going to assume this one as my center. So this will be what? This will be my right angle triangle. I will be having a 90-degree angle here. This will become my right angle triangle, right? So I will be having a perpendicular which is of 2 centimeter. If this is 1, let's say this is 2 centimeter arc here. I will be joining this one. Then I will be finding out this length, which is what? It is root 5. Putting it here, I will be marking the point. Let's say this is what? This point is root 5. Or you can just do what? Put the compass here, open up the compass, point out the arc there. That will be what? That will also be your, actually it will be meeting it here. That will be what? That will be your root 5. The choice is yours. You can even assume that method also. There is no doubt in that. You can get that answer correct also there. But if you want to assume this one, that is also true, because we were exactly doing it like this, right? That was the base, which was 1 centimeter. I was assuming this to be the right angle triangle, where I was assuming my origin to be my right angle triangle's point. So if this was my 90, this was 1, this arc was 1. Joining them, I will still be getting the same hypotenuse. If that was the case, I will be having this hypotenuse as my arc of compass, putting it at the origin. I will be marking the point. That point will be root 2, or you can say whatever that is. So either you can do it like this or you can do it like this, but I want you guys to prefer this method because that some teachers not find valid. Although it is true, we can solve this one with this method also, but if you can follow this one, that is well and good. You have to do what? Just take the base, put the point, draw a right angle there, join them, marking the arc of your perpendicular, then using that arc as your using the length of your hypotenuse as the arc of your compass, pin out the location where that would be your required irrational number. So I hope you guys have understood the case and you don't have any doubt in this. So this will be it for representing an irrational number 9. So I have one more question for you guys since we are on it. So if I want you guys to represent root 6, how will you be representing this on number line? So you will be doing it like this, right? Square root 5 whole square plus 1 whole square. You can do it like this. Now for this, firstly you have to pinpoint your square root 5. Then assume that one as your base. Put the perpendicular 1 centimeter. Then you can easily solve that one. You will be getting your 6, right? Since we had done it like this, since let's say, or you in order to put out a root 5, I will be doing what? Marking our base of 1 centimeter, drawing a right angle there, putting an arc of 2 centimeter there, joining them, taking this one as the arc of my compass, pinpointing the location of root 5. This will be root 5. Assuming this root 5 to be base, again constructing a right angle, joining this with center, using this as the arc of my compass, pinpointing the location by actually obviously we have to firstly mark our perpendicular there. So our perpendicular is of 1 centimeter here, so that should be the case. Marking this one, using this length as our length of the arc, pinpointing the location, that will be what? That will be a root 6. So I hope you guys understand this. This is how you can represent your any irrational number on number line. Given that irrational, it does not matter whether that rational number is positive or negative. Even you can represent negative root 5 also. That will be on the other side of 0. So it does not matter whether the number is positive or negative. Irrational, just remember this, it cannot be like this. Your number inside the square root has to be your natural number. It cannot be even whole number. We cannot represent square root 0. That would be an undefined case. So remember this, it has to be a natural number inside the square root. It cannot be a negative integer. Then you can easily represent that value on the number line. If it is a negative square root of any natural number, that will be on the other side of 0. If it is positive, that would be on the other side of 0. So I have given you two methods. If you prefer this one, that is well and good. You can even use that one also. No worries there. You will still be getting the same answer. So I hope you guys understand this, right? Now with this, since I have one more case here, we are going to start with the next exercise because this exercise was short. So let's just jump to the next part. So now this is the main thing that I want you guys to understand. This is the case of decimal expansions of your rationals and your irrationals. This is what I was talking about earlier when I was writing the difference between your rationals and irrationals. See, here I want you guys to specifically understand what is the difference according to their decimal expansions. Now you guys see, you guys already remember your rational numbers are what? These are in the form of p by q, right? So let's say I have some examples for you guys and you guys will be telling me the decimal forms of that. So if I ask you what would be the finite answer if I divide 2 with a 5, what would I be getting? I want the answer to, I want remainder to be 0. It does not matter what would be, how many decimal places would be there. Now guys see, if I simply divide this one, you guys can easily divide this, that will be what? A 0.4. You guys will be telling me that sir, this answer is terminating, it is actually giving me a remainder 0 and we have just one digit after decimal and after that we don't have anything. So when your answer ends at any given place in your decimal, that answer or that decimal expansion happens to be your terminating decimal expansion. The word itself states clearly terminate. It belongs to terminate, right? It is related to terminate. Terminate means to end something. Now our division will be ending where? When we have our remainder which is 0. So once we have the remainder 0, we can say that our decimal expansion is terminating. So rational numbers can have terminating decimal expansion provided if they have their divisors, if they have their divisors in the form of 2 raised to power m or 5 raised to power m. If their divisors have the factors of this form, that means you guys see we had a 5 here, this was completely divisible. Let's say if I have 40 by let's say 200, this will also be divisible. Let's see if I solve this one, this will be what? A 0.2. So you guys see, as long as we have our divisors in the multiples of 2 and 5, we can say that our number or our division will be terminating. So our rational number will be giving us a decimal expansion which will be terminating, as long as it has its prime factors to be 5 or 2 and their any power. They can be risen to their any power, but they have to be either 2 or 5 as their prime factors. That is the prime motive here to understand the case of terminating. Now what to do if we don't have any prime factor which is either this or that? See, what can happen here is that either we can have only 2 raised to power m as the divisor, or we can have 5 raised to power m as the divisor, or we can have multiplication of these two as the divisor. There cannot be any other thing. Now what to do if we have something like this? If I erase this and if I give you a number 1 by 3, if I ask you what would be the decimal expansion of this, will this answer be terminating at any given point? If I want to ask you whether you will be getting a remainder 0, just let me know whether you will be getting the remainder 0. See, it will be this. If I tell you, if I divide this one quickly, you have what? You will be taking a decimal, that will be a 3 here, that will be 10, 9. Again, you will be having a 1, a 0, you will be having a 3, that will be 9, 1, 0, 3. And you guys see this number is keeping on repeating. That means in your quotient, you have 0.333. That is happening continuously. It is not ending anywhere. And at any given point, your remainder is just 1, or you can just go on, that will be 10. Then you will be getting a 1. Again, it will be 10. Then you go on, that will be 10, 10. And you guys see, you are not getting any remainder which is 0, but you are surely getting what? You are surely getting quotient which is non-terminating. These kind of expansions are what? These are your non-terminating expansions. But there is one more case here. See, every number is repeating here. So we will be calling this non-terminating expansion, but repeating. So you guys see, in rational numbers, we can have only two kind of decimal expansions, which will be what? It will be either your terminating decimal expansion, that means you will be getting the remainder 0, or it will be what? It will be non-terminating decimal expansion, but that will be repeating. Remember this, that will be repeating here. So you guys see, that is the case here. If I give you one more example, let's say if I want you guys to divide 11 by 9, you guys solve this one, you will be getting what? Let's see, if I divide 11 with the 9, I will be having what? A 9, that will be 2, that will be 20. If I take decimal here, that will be 20, right? Then again 2, that will be what? 18, 20, then 2, then 2. You guys see, this is again repeating. So you guys see, just 1 did not repeat. After decimal, 2 is keeping on repeating, right? So this is what? This is another case of what? Your decimal expansion which is non-terminating, and it is what? It is repeating also. So I hope you guys understand this, right? Now let's see what to do when we have the case. Now we have the decimal values. We have two values, whether terminating or non-terminating but repeating. So what do we do if we have these kind of expansions and we have to represent in the form of p by q? If it is non-terminating and repeating, we can easily represent that. If it is terminating, then it can be easily represented in the form of p by q. How is that possible? Let's see. If I take the example from previous case, if I give you this value 0.2, you can easily represent in the form of your fractions, right? You will be doing what? Just removing the decimal, putting a 10 here, that will be what? A 1 by 5. So you have the value which is in the form of p by q, right? If I give you, let's say 1.004, and I want you guys to represent this in the form of p by q. Initially you can do what? You can just remove the decimal, there will be what? 1000 at the denominator. So this will be what? This will be in the form of p by q, although this is not in the lowest form. That means it will be divisible on common multiples. You can divide them. You will still be getting the answer which is in the form of p by q. Understood? That is the case. But what to do when we have a non-terminating expansion, but that expansion is repeating? Firstly, remember this. If we want to represent any decimal value in the form of p by q, it has to be of these two forms. Either it can be terminating or it can be non-terminating, but it has to be repeating. If there is any case that your answer is non-terminating, like for the case of square root 2, you guys remember that answer was not terminating, it was non-terminating, it was just going on dividing. So you guys see its quotient was not ending anywhere in any place of decimal. So for that case, that was the case of a non-terminating and non-repetitive scenarios, your decimal expansions. So for such cases, you guys remember, always keep in mind, once you have a value or a decimal expansion in which you can see the answer is non-terminating, you have these dots there, but the values are even not repeating, the values are not repeating after any particular limit, then you guys should be having the picture in your mind that number will be what? It will be an irrational number, and that number can never be in the form of p by q. So once you have the decimal expansion in which nothing is repeating but the answer is non-terminating, that is irrational number. Forget that, that will not be represented in the form of p by q, because the definition itself states that irrationals cannot be represented in the form of p by q. So that is what I want you guys to understand. Now let's see, if I have a non-terminating but repetitive number, how we are going to represent that in the form of p by q. For the sake of argument, I am going to assume this one, 3, 3, 3, 3. And let's see if the number is repeating, right? Then you can do what? You can put over the vernaculum, or you can say your bar, over those digits which are repeating. In this case, we have only 3 which is repeating, so I will be putting the bar over 3. Let's say if I had something like this, 1, 3, 1, 3, 1, 3. Now you guys see, 1, 3 is repeating continuously. So this can be written like this, 0.13 per. And you can see if we have this 0.133, 133, sorry. If we have something like this, 133, 133. Now you guys see in this case 133, all 3 digits are repeating, so you will be writing it like this, 0.133 per. That means this can be represented in this form, or this can be represented in that form. So that is the representation of a non-terminating but repetitive decimal expansion. Now we are going to convert each of these 3 cases in the form of p by q. So firstly, assuming this one, do what? In a very first step, just always assume x to be your 0.3 bar, or you can say x equals to 0.333 dot dot. Mark this one your first equation, right? Then count the number of digits which are repeating. In this case, we have only 3 which is repeating. Now you just pick one, put as many zeros as the number of digits which are repeating. Now guys see, we have single digit which is repeating, so I will be putting a 10 here. That means it will be a 10. It will be, I will be putting a 0 there. I will be doing what? Multiplying 1 with 10. Whatever we had taken here, I will be multiplying both sides. So this will be what? A 10x, and that will be what? If you multiply this with a 10, this will be what? 3.333333, and this will be going on. Right? Now you have 2 methods here. Either you can mark this one as the second equation, but I can tell you the easiest method of this. Don't just go with the elimination one. Can you write this one like this? 10x equals to 3 plus 0.33333. Obviously you can. Now guys see, you guys remember the value of 0.333 and so on, it was what? It was an x. So if I replace the value here, I have what? I have this 10x, which is equal to what? 3 plus x. So 3 will be what? It will be 9x. X will be what? 3 by 9, or you can say 1 by 3, which is in the form of p by q. So hence you have just proved that 0.333 or 0.3 bar, it is actually the value of 1 being divided by a 3, or you can say that is the form of p by q. You can do it with this method, or you can do with one more method. In that you have to do what? You will be just dividing your 2 equations together, or you will be subtracting that. So let's just subtract our 2 equations. So firstly, let me just name our this new equation as a second equation, we will be doing what? Subtracting 2 and 1. So 10x will be here, it will be what? 3.333 bar, or you can say dot dot dot, and we have an x here which is equal to 0.333 dot dot dot. Now you do what? Just subtract them, assuming this and putting a negative sign here, negative sign here. This will be what? A 9x. Now you guys see 3.333 and so on. Subtracting 0.333 and so on. This portion will be cancelling out. You will just be having a 3 and your x will be what? 3 by 9, which is what? A 1 by 3. So in short, you have your answer, which is what? It is 1 by 3. So I hope you guys have understood the case here, right? Now let's see if we had this one, that would have been a different case. Let's see if we wanted to do it like this. If we wanted to represent 0.13 bar in the form of p by q, then what we would have done? We would have done it like this. Firstly, assuming this same as our x, so let x equals to 0.131313 and so on. Then I will be doing what? I will be counting the number of digits which are repeating. In our case, we have 2 digits which are repeating, so 1 followed by a 20, that means 100. Multiply this with what? This is our first equation, so multiply 1 with 100. So I will be having what? 100x, which is equal to what? Now if you multiply this with 100, you will be having a 13 here, 13.131313 and so on. Now choice is yours. Either you can assume this your second equation, then you can subtract them, or you can do what? You can just expand this one, 13 plus 0.131313, and you guys see your 0.131313 and so on. It is what? It is your x. So 100x equals to what? 13 plus x. It will be what? 99x, which is equal to 13. X will be what? 13 by 99. So this will be the case here. So that will be the form of p by q. I hope you guys have understood the case, right? So similarly, you can represent any decimal value. Just one more case for you guys, then I will be shifting towards our exercise. So what to do if we have something like this, 0.12 and bar over 3. Like I see, this is a very important case. Remember this is very important. You have 0.12 but a bar over 3. Now what you can do with this? In this case, you can write it like this. Firstly, 0.12333. Put this against your x. Assume this one to be your x. Now you guys remember, just 3 is repeating, not 12. So firstly, we have to do what? We have to pick this 12 out. Then we can assume our 3's. So in this case, we are going to do what? We are going to take these 3 out. So you guys remember, we have 1. I have to take these 2 out, and along with this 3, I will be multiplying this with what? 1000. So you guys see, if I just multiply this with 1000, I will be having what? 1000x, which is equal to what? 123.33333. And we have our x, which is what? Our x was 0.123333, right? That was the case. Just subtract them, do nothing about this. Minus here, you will be having what? See, this will be cancelling out, and so on, everything after that. 3 minus 2, that will be 1. 3 minus 1, that will be 2. That will be what? 123.21, which is equal to what? 999x. So x should be what? 123.21 over 999. Now you have to do what? Just remove the decimal here, put 2 zeros here. So this will be what? 12321 over 99,900. That will be your answer, which is in the form of p by q. So I hope you guys have understood the case. There is one more method for this one, but I hope you guys have understood this one. So I won't be confusing you with one more method, but that will be a more confusing one. So let's just keep it here. So I hope you guys have understood the case and you don't have any doubt in this, right? So with this, we have this one. You can easily solve this. If you want to solve this one, just note this down in a notebook and attempt the question on your own. We have what? Represent 323232 in the form of p by q. This will be easy, right? This will be x. We will be assuming it to be 323232 and so on. Then I know 2 digits are repeating. I will be multiplying this with what? You guys remember that? I will be multiplying this with 100. Then you will be having 100x, which will be what? 32.3232 and so on. So you can solve this one easily. You will be getting the answer. That will be what? 32 over 99. That will be your x. Right. You can do this one. That is totally on you. Right. Similarly, you have this one 0.1232323. Now you guys see 1 is not repeating, but 232323 is repeating. So that means this is quite similar to the one where we had done it like this 1.23 bar, 0.123 bar. So you can easily solve this one, right? You can just write down this in your notebook and put this as your homework. You can easily solve this. And following this up, again we have this case. In this case, we have 1 out of the decimal. Now here you will be taking just 2 out and a 3 out. So you will be multiplying this with what? 100. This can also be what? Your homework. You can easily solve this. If you have any doubt, we can just come up with this doubt session tomorrow, right? You can ask me there. I will be easily solving this for you. But that will be your homework. And let's see. So this is your example 6, in which we have what? Show that this is a rational number. In other words, express this in the form of p by q. Now guys, see, nothing is repeating after this and you don't have any bar over this. This can easily be written like this: 3.142678. Remove this, divide this with what? A 1 followed by 2, 4 and 6 zeros. So that is what? That is in the form of p by q. Then you have to just divide this one. So you can just cut them out on similar common factors. Then you will be having your values in the form of p by q in the lowest form. So this was the answer of this one. And in the next case, we have what? We have already done this question, 0.33 bar. We have already represented that. That will be what? A 1 by 3, right? Then we had this one. We had to represent this in the form of p by q. You guys see 1 is already out of the decimal. So you have to just keep a pair of 27 out of the decimal. So you will be multiplying this with what? 100. That will be what? 127.272727. You will be subtracting 1.272727. This will be what? 126, which will be equal to what? You have just multiplied this with 100. That will be a 99 there. So x will be what? 126 over 99. This will be cancelling out at 3. You will be having 43 over 33. So that will be the case. You will be getting the answer in the form of p by q, right? So sums are easy. You can easily do them. So let's see, what do we have now? Similarly, you can do this one. You have what? 2.35 bar. Now you guys see 2 is not repeating, but 35 is repeating. So you will be multiplying this with what? 1000, and you can easily solve this one. Since we have already done this question also, 0.123 bar. We have already done this one. So you can easily solve this. If you have any doubt, you can just ask me and I will be discussing that in your doubt session tomorrow also, right? We can take your doubts also. So these are your sums from your exercise. We have to do what? We have to find out what kind of decimal expansions each has. Now you guys see, we have to find out whether that we are terminating or a non-terminating decimal expansion. Now you guys see, we have 100 here, which is a multiple of 2 and 5 both. This will be what? This will be terminating, or you can say this is 0.36. Easy. Now guys see, we don't have any prime factor which is in the form of 2 raised to power m or 5 raised to power m. That means this will be what? A non-terminating expansion. Now in this case, you have what? 8, which is 2 raised to power 3. This surely be what? It will be terminating. If you guys remember, that will be terminating. Now in this case, again, we don't have any 2 raised to power 5 or 5 raised to power 5 as the prime factors. This is 13. That will be what? Non-terminating. This will also be non-terminating. 400 is what? It is 20 into 20, and you guys see it is what? 2 raised to power 2 into 5 x whole square. So you guys see, this will be what? This will be terminating again. So these were the answers. I hope you guys were able to guess each and everything. You don't even have to divide them. You can just easily check for the divisor whether that is in the form of 2 raised to power m or 5 raised to power m, or it is a common multiple of both. Then you can say that answer will be terminating. If there is nothing like that, then answer will be what? It will be non-terminating. So I hope you guys have understood the case, right? So in this, you have to find if you have what? You have this 1 by 7 has this expansion. Can you predict the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7? Now hint is also there, but this is very easy. You guys see 1 by 7 is what? It is 0.142857 bar. That means all these 6 digits are repeating. If you want to find out the value of 2 by 7, can you write it like this? 2 into 1 by 7. So whatever the decimal expansion of 1 by 7 is, just multiply that with 2. So it will be what? let's see, it will be what, a 14, that will be an 11, 16 and 1 17, that will be a 5, that will be an 8, that will be a 2. So it is what, 0.285714. Similarly, you can find out the value of 3 by 7, 4 by 7, 5 by 7 or 6 by 7. So I hope you guys understand this. Now in these cases you have to represent them in the form of p by q. We have already discussed various cases. You can easily solve them. So practice them. That will be your homework. And this will be, I probably think, your last sum. See, we have what, 0.999 in the form of p by q. We have to represent this in the form of p by q. And we have to see whether you are surprised by this or not. Just attempt this one. You have what, 0.999 ... That means each 9 is repeating only. So I will be multiplying this with a 10, assuming this equal to x. So multiplying this with 10, multiplying this with 10, I have what, 10x, which is equal to what, 9.9. Just subtract these two. So x equals to 0.999. Now you guys see, subtraction, that will be 9x and that will be 9. So your x is what, it is 1. But you guys see, we had the decimal expansion which was 0.999, but our answer turned out to be exactly 1. So how 1 by 1 will be same as this one? See, that is pretty easy. You guys see, this answer is pretty much close to your 1. So if you represent this in the form of p by q, you will be getting a 1 there, because the answer is very near to 1. So it cannot be any other thing than 1. So I hope you guys have understood the case, right? And we have this one. You have to find out what can the maximum number of digits be in the repeating block of the digits in the decimal expansion. You have to find out after how many digits the numbers will be, or the digits will be repeating themselves. That means after what place the digits start to repeat themselves. This is very easy. You have to divide this on your own and check for the answer. You will be getting something around 14 digits. After 14th decimal, your answer will be starting to repeat itself. Your quotient, the digits in the quotient, they will be repeating. I am thinking about 14. It can be anywhere near that, or even 1 or 2 steps ahead of that. So you can easily solve this one. And so today what we did, that is the summary case. Now we understood the difference. We understood the case of representation of irrationals, right? We represented as root 3, root 2, root 5, anything on the number line, right? We have represented them on number line. Then we understood the case of our terminating and non-terminating decimal expansions, but repeating. So you guys remember, terminating was what? When you had the remainder 0. So on division, once you had the remainder 0, that answer was terminating. But if you did not get any remainder which was 0, that means your answer was non-terminating even in your decimals. But if in decimals the numbers were repeating themselves, or the digits were repeating themselves, those kind of expansions were your non-terminating but repeating expansions. Then we had understood how to represent both of these in the form of p by q, and that was it. We had just represented as 0.333 bar, like, right? So we had done this one. So your homework will be completing your exercise, which one, 1.3, I guess, up till your 5th question. I'll see you tomorrow for your next session. Bye for now. And remember, you have to practice as much as you can. You cannot just skip any day. You have to practice each and every day. And don't think this topic is very easy. You guys already know this. You have to practice that topic also, because easy topics and tough topics, both are the parts of your syllabus. So you cannot skip any of those. See you then. Bye for now.